Hello all, welcome to our channel. So in this video we will talk about DHT11 sensor, which is a relative humidity and temperature sensor, which is commonly used by hobbyists worldwide. And if you are beginning with boards like Arduino, you find lot of resources about this over the internet. So let us talk about the DHT11 sensor. So DHT11 sensor, right? It operates between 3 to 5 volts. So if you are seeing 5 volts, that means it can be directly connected to Arduino, and the maximum voltage you can give to this is 5.5 volt max, beyond which it gets damaged. So ensure that when you are applying voltage, you don't give beyond that. And when it operates, the very important point which the designers have to keep in mind is the operating current. So the operating current is between 0.5 milliamps to 2.5 milliamps. So if you are thinking of a low power application, this is very huge, right? So while using it in your application, ensure that you select another sensor if power is critical in your application. And then you can see standby current, which is 0.15 milliamps, which is again on the little higher side, that means 150 microamps. It can drain your battery easily, right? And the temperature range, it can detect between 0 to 50 degrees centigrade, which is enough for your applications where if you want to use it as an environmental sensor, or if you want to use it in your house to detect the sensors, or if you just want to use it in your fish aquarium to detect the temperature and adjust the temperature accordingly. So many applications you can think of. And then relative humidity, it measures between 20% to 80%. So the relative humidity is basically the water vapor content in the air, right? So you can read about the relative humidity. And then accuracy is very important characteristic of any sensor, specification of any sensor, right? So the temperature accuracy is around plus or minus 2 degrees centigrade, whereas relative humidity accuracy is around 5%. So relative humidity is measured in percentage, whereas temperature is measured in degrees centigrade by the sensor, and is output as well in the same spec. And then you can sample the sensor at 1 Hz. So 1 Hz is little slower, right? So this basically sensor, as I mentioned in the beginning, this is used mostly in the commercial space, where low cost is involved, or by hobbies mostly. If you see the sensor has 3 pins. So the electrical interface, if you want to connect it to a microcontroller, that's what we do, right? We interface the sensor to a microcontroller and then read the sensor output on the microcontroller pin. So we have VCC, ground and signal. VCC, as we mentioned, it operates between 3 to 5 volts. And then the signal, the very important point, DHT11 has a digital output. It's not analog. So that's a very advantageous situation. You don't need the analog peripheral to be used on the microcontroller. It's just a digital pin, and it outputs the values on a signal which can be connected to a digital pin on your microcontroller. Example, if you have Arduino connected to a digital pin of the Arduino, and you can start reading. Only one requirement from the hardware perspective is you need a pull-up to the operating voltage of VCC. Remember that if you are interfacing it to a microcontroller of 3.3 volts, ensure that you give 3.3. If you are using a Arduino kind of board where the controller interfacing is at 5 volts, you use 5 volts for DHT11. A very important point when you are using it in the hardware. And then if you are going through different DHT11s that are available in the market, actually there are 2 types. One is 3 pin and the other one is 4 pin. You can see the major difference between them. The 3 pin DHT11 is on a PCB, whereas 4 pin it's a individual sensor without any PCB. So what's the difference? Basically you can see here, 4th pin, it's not the 3rd pin of 4 pin DHT11 is not used. So we use only 3 pins. So this 3-pin DTH11 actually helps us to reduce that pin count and eliminate any unintentional connection to this third pin, by providing only 3 pins. So you have serial data, VCC plus, and ground, which are only 3 pins, and you connect your serial data, that means the signal pin, to the microcontroller directly. So a very, very important point. So when you are selecting, ensure that most preferably you try to use the 3-pin DTH11, or if you want to have the sensor at low cost, try to go for 4-pin DTH11, so that this PCB cost reduced, which won't be too much of difference. This sensor itself comes around 60 rupees INR, and if you buy in bulk it will be much lesser. So that's one of the consideration you have to take while using it. And then another important point which you have to remember is, this basically is a single digital pin that connects to the microcontroller. So there is some protocol associated from the DTH11, so that a microcontroller understands the language from the sensor. So for this, what happens is, initially the microcontroller sends a small low pulse which is around 18 milliseconds. You can see here, if we go little backwards, if you see this interfacing, there is a pull up here. So that means when there is no communication on this channel, the channel will be high. Okay, so it will be high, and then there is a pulse of 18 milliseconds that goes low, that is made low by the microcontroller, and then again it is made high. So if this kind of pulse is received by the DTH11, that means the microcontroller is asking the DTH11 to start communication, and once the DTH11 receives this, it responds by sending this pulse. Okay, this basically is initially a low of 54 microseconds and high of 80 microseconds. So this means the DTH11 is ready to respond, and then post this response, immediately DTH11 starts sending the data in 5 segments. 5 segments means each segment is 8 bits long. So that means byte. So there are 4 bytes of data. What happens is, 5 bytes of data. Okay, so a total of 40 bits. So if you see, first byte of data and second byte of data represents the relative humidity data, and the next 2 bytes represent the temperature data, and post this, it sends a checksum of 1 byte, which is a simple addition of these two. So you can be easily identify the checksum at the receiver end and understand that accurate data has been received. So this, if you see here, if you send a 0, if DTH11 sends a 0, this is the pattern that you will be sending, and if the DTH11 sends a 1, it sends this pattern. So you can see here, these patterns are what microcontroller has to read, and if you see the timings here for this particular sensor, you can understand the timings are very, very critical. So if you are using the sensor, you have to ensure these timings while reading on the microcontroller pin. So a simple sensor, but a timing sensitive sensor which microcontroller has to handle it at its end. Hope we made clear on few of the points of DTH11. Please post if you have any questions. Thank you.